Here we look at some definitions of different numbers. First of all, natural numbers. These are 1, 2, 3, 4, 5, etc. Whole numbers, we include 0. So 0, 1, 2, 3, pretty much positive integers plus 0. And integers, that will include all 0 and positive 1 and positive or negative 1, positive or negative 2, positive or negative 3, and so on. Now, rational numbers, a rational number is a fraction. So if you can write a number as a fraction, and then it is a rational number. So first of all these numbers, natural numbers, whole numbers, integers, so all of them are rational numbers because we can write all the integers, any integer. If I use I to represent integer, any integer I, you can write it as I divided by 1 because I divided by 1 is still I. So I over 1, that's also a fraction. So all the integers are rational numbers. Well, but there are numbers which are not rational numbers, which means there's no way we can write it as a fraction. For example, square root of 2, square root of 3, and square root of 5. All of these numbers are irrational numbers because we actually can prove there's no such fraction that make square root of 2 equal to that fraction. So this is never going to happen. You cannot find integers a or b such that a divided by b you can get a square root of 2. And this can be proved. Okay, so rational numbers and irrational numbers, we put them together, that's called real numbers. So if there are real numbers, that means we also have unreal numbers, which we call them imaginary numbers. Such as 2i, negative 3i, and so on. Well, if we put real numbers and imaginary numbers together, we get complex numbers. So it has a real part, for example, 1 plus 2i. So 1 is the real part and 2i is the imaginary part. So if we draw a circle to describe the relationship between these numbers, number sets, well, we can put the numbers in the set notation. Then each of them becomes like a group. So set of natural numbers, we use n to represent all the numbers as a group. And whole numbers, we use w, set of whole numbers. And for integers, we use z. We actually did not take the first letter. It's probably because I will be confused with the imaginary unit I. So z represents the set of all integers. And the rational numbers, we use q as set of all rational numbers, which also means fractions. And irrational numbers, we don't have a symbol for that because rational and plus irrational numbers, all of these together, that would be a real number. So real number set, we do have a symbol for that, that's R. So R means set of all real numbers. So when we talk about irrational number set, we can use R, set R minus all the rational numbers. So if we draw a circle to represent, this is all, we put all the natural numbers in this circle. And then if we add 0, we will get our whole number set. And then if we add all the negatives and negative integers, we will get the integer number set. And if we add other fractions other than fractions of this format, we will get, for example, such as 1/2, 2/3. These cannot be simplified to integers, and we will get all the rational numbers, which is q. And be careful actually, because we did not take r, because we use r. We saved r for the real number set. And then we add square root 2, square root 3, all these irrational numbers, or we call them radical numbers. So we add these, we will get the real number set. And if we add imaginary numbers, we get the complex number set. But usually, I guess in this class, we will focus on real numbers. Well, are there any numbers besides complex numbers? So we can expand the numbers to an even bigger circle? Well, yes, we do, but that's sort of like a high-level math. In abstract algebra class, we will learn, it's modern algebra, we will learn more numbers other than complex numbers. Okay, so these are some definitions of different number sets and the symbols for them. So we will be using these symbols in a lot of math subjects.